Did you know that living next to a nuclear power plant for 1 year gives you 100 times less radiation than eating a bag of potato chips every day for 1 year? Hi, welcome to another episode of Chemistry is Easy with Mr. Jesse. For this tutorial, we are going to answer sample questions on band of stability. These questions came out on last year's system-wide quiz. Using the number of protons and neutrons, answer questions A and B. Explain how it is possible to predict whether or not an isotope is likely to be stable. The stability of an isotope has something to do with its neutron to proton ratio. So isotopes are likely to be stable if their neutron to proton ratio is in the range of 1:1, meaning 1 neutron is associated with 1 proton, or for every 1 neutron there is 1 proton, or 1.5:1. So this is a simplified ratio. An example would be for every 3 neutrons you will have 2 protons. If we simplify this ratio, it is going to be 1.5:1. So for atomic numbers that are less than 20, the ratio of neutrons to protons would be 1:1, and it is going to gradually increase as the atomic number increases up until the ratio of 1.5:1. Part B. Explain how it is possible to determine the lightest isotopes and the heaviest isotope. Now, the lightest isotopes has a neutron to proton ratio close to 1:1. So this ratio again is applicable for nuclei with atomic number less than 20. Now, as the atomic number increases, the neutron to proton ratio is also going to increase until 1.5:1. So therefore, heaviest isotopes would have a ratio close to 1.5:1. So given number of neutrons versus the atomic number graph, identify the regions X or W, X, Y, or Z where you can find each of the following. So the first type of nuclei that we have to locate is a stable nuclei. Now, a stable nuclei is the nuclei that is close to the band of stability. So therefore, very obviously, we could find a stable nuclei in region W. Second type of nuclei. So where can we locate the nuclei that can undergo beta decay? Now, radioisotopes that will undergo beta decay are those isotopes that have too many neutrons and therefore found above the band of stability. Hence, we can find nuclei that could undergo beta decay on region X. Now, this is because they will undergo beta decay in order to convert their neutrons into protons and thereby decreasing the number of neutrons. So when the number of neutrons would decrease and the number of protons would increase, they would eventually fall within the band of stability, and therefore the isotope becomes stable. So once again, nuclei that can undergo beta decay are found above the band of stability. Next type of nuclei, a nuclei that can undergo alpha decay. Now, nuclei with atomic number greater than 82 will undergo alpha decay. Therefore, based on the graph, anything from this point beyond would have an atomic number greater than 82. Therefore, those nuclei on region Y will undergo alpha decay, since again, based on the graph, their atomic numbers are greater than 82. Let's come to the last type of nuclei on this table, the nuclei that can undergo positron emission. Now, positron emission occurs when there are too many protons compared to the number of neutrons. Therefore, based on the graph, nuclei on region Z will undergo positron emission. And it is because their number of protons, or related to the atomic number, so this is number of protons, is actually greater compared to the number of neutrons that they have in their nucleus. So therefore, they will undergo positron emission to decrease the number of protons and increase the number of neutrons. And on the process of doing so, a positron is being emitted. So again, the nuclei that can undergo positron emission can be found on region Z. Are radioisotopes above the band of stability stable or unstable? Explain. They are unstable, and this is because they have too many neutrons relative to the number of protons. Also, if this is the band of stability, any nuclei that can be found below the band of stability, for example in this region here, they are also unstable, and it is due to the fact that they will undergo positron emission. They have too many protons, and the ratio of neutron to proton is not appropriate for those radioisotopes that are for those isotopes that are considered to be stable. What type of emission does calcium-35 emit? Justify your answer. So if we're going to write calcium-35 in symbol, it is going to be calcium, and we have 35 here as the mass number, and the atomic number of calcium is 20. We could check this out in the periodic table for the atomic number. Now, this means then that the number of protons of calcium is 20, and the number of neutrons would just be equal to the mass number multiplied by the atomic number, and that gives us 15. So that means calcium-35 has 15 neutrons. If we are going to graph this in our number of neutrons versus atomic number graph, for the number of protons, that is actually related to the atomic number, so we have 20. Let's symbolize it with a green line. And the number of neutrons would be 15. The intersection would mean the location of our calcium-35, and it is actually below the band of stability. Therefore, calcium-35 will undergo positron emission because it lies below the line of stability or the band of stability. Once again, remember that anything that lies below the band of stability is unstable and will undergo positron emission. And that concludes this tutorial. Once again, always remember, chemistry is easy with Mr. Jesse.